Okay, in this video I want to show you a little bit more about the derivatives involving trigonometric functions. And in this case, in these examples, I'm going to use the rules that we just learned for trigonometric functions to find the derivative of the basic trigonometric functions. And I'm going to use all of the previous rules to find derivatives. So for example, I'm going to start with this function y equals minus 2 multiplied by sine of x. Remember that this x is not multiplying sine, right? This x is inside the sine function. Okay. Well, in this case, you can remember we have a constant c, and this is our function. So we are going to proceed in pretty much the same way as before. We have a constant, and we are going to find the derivative for the function, and then we are going to multiply by that constant in the end. So y prime is going to be my constant multiplied by the derivative of sine of x, which if I use all the steps in the rule to find the derivative of the sine function, I will say if this is because this is u is x, then my derivative is going to be 1 multiplied by the cosine of u, the cosine of x. So this is the derivative. Okay, I just finished differentiating this. I have my constant c, and I have my derivative here, the derivative of the sine function. So in the end, I'm just going to get rid of these parentheses and the brackets. So I'm going to have minus 2 times 1, which is minus 2, multiplied by the cosine of x. So this is my answer. That is the derivative of minus 2 times sine of x. It's going to be minus 2 times cosine of x. Okay, so as you can see, I used my rule for the sine to find the derivative of the sine function, and then I used the rule that involved a constant multiplying my function. Okay, I want to work with another example. In this case, I want to use my second example. I want it to be y equal to 2 plus 3 cosine of x. Okay, so this is my function. So I want to find the derivative. As you can see, I have two terms, this one and this one. Okay, 2 is one term, 3 times cosine of x is another term. So I'm going to find the derivative of those two terms. Okay, and well, my derivative of the first term is going to be 0 because this is a constant, right? And then plus the derivative of 3 cosine of x. So again, I have a constant. Okay, let me just erase it. I have a constant here, and I have my function here. Okay, so I'm going to work this example, or this term, to find the derivative of this term, pretty much the same way as the last example, the previous example. I have my constant 3, and I'm going to multiply it by the derivative of cosine of x. So if I use the rule to find the derivative of cosine of u, remember this is u is x, and then u prime, the derivative of u is 1, because the derivative of x is 1. Okay, so I'm going to have a negative, that's my rule, u prime 1 times sine of u, which in this case is x. Okay, so this is the derivative. Okay, I just found the derivative. I just need to simplify now. So it's going to be y prime equals minus 3 times the sine of x. Okay, this is 0. I'm not going to write anything there. So a negative times a positive is a negative. 3 times sine of x. This is the derivative. Okay, let's work with another example. Okay, I think they will be useful. Let's say example number 3. Okay, I have a function which is y equals cosine of x divided by x. Okay, I have this function. So as you can see, I have a quotient, so I'm going to use the quotient rule. This is u, this is v. So as you can remember, our rule said v times the derivative of u minus u times the derivative of v, everything divided by b squared. Okay, so maybe I can write it here on this side. U prime. What is u prime? I think we just found the derivative of cosine of x in the previous example. It is a negative sine of x. Okay. And if you want to remember how we got that, just go to the previous example. That's a good thing about these videos. You can rewind it and play it as many times as you need. And v prime, the derivative of v is going to be 1 because the derivative of x is 1. So I'm just going to use my quotient rule. It's going to say, okay, v squared down in the denominator. Okay, v squared. This is v squared, x squared. Now the rule says, write v here, the denominator. Okay, just copy the denominator. Then multiply this by the derivative of the numerator, the derivative of u prime. U prime is minus sine of x. So minus sine of x. Okay, and then minus, that's the rule, it's going to be a subtraction here. Your numerator, cosine of x, just copy, times multiplied by the derivative of the denominator, b prime 1. Okay, so this is my derivative. Okay, I'm done differentiating. I just need to simplify. Okay, I have x squared down here and negative x times sine of x. Okay, please do not try to multiply the two x's, this one and this one. You cannot do that. This x is inside the sine function, the trigonometric function, so please don't touch that x. Okay, so let's continue with our example. Minus cosine of x times 1 is cosine of x. That's it. I cannot simplify anything else, I think, and that's the answer. Okay, this is the answer. Okay, another example. Okay, just two more. Okay, I'm going to solve 2 more examples. We are up to example number 4. So I want it to be y equals sine of x, which is going to be multiplied by cosine of x. Okay, I have a product, so some of you already know that I'm going to use the product rule. This is u, this is v. So the product rule says your first factor u multiplied by the derivative of the second factor v prime plus v times u prime. Okay. The second factor multiplied by the derivative of the first factor. So I can work here on the side if you want. I think it will be clearer to some. Okay, easier to understand. So what's the derivative of sine of x? We just did that in the first example. The derivative of sine of x is cosine of x. If you want to know how I got the derivative of sine of x as cosine of x, just refer to the first example. And the derivative of v, which is cosine of x, is a negative sine of x. Okay, I just used the basic trigonometric rule for the derivative of the cosine of x. So I'm sorry, this is the derivatives. I'm sorry, and okay, so I'm just going to use my product rule. It says write u, okay, sine of x, multiplied, but that's why I'm using parentheses, multiplied by v prime, the derivative of the second factor, which is the derivative minus sine of x. Then plus, that's my rule, write the second factor v, just copy, and then multiply by u prime, the derivative of the first factor, the derivative of sine of x, cosine of x. That's it. This is the derivative. So I'm just left with the simplification of this. It's going to be a negative times a positive is a negative, sine times sine of x is sine squared of x, plus cosine of x multiplied by cosine of x is cosine squared of x, and that's it. This is the answer. This is the derivative of that function sine of x multiplied by cosine of x. Okay, I think that's it. That's everything for this example. And my last example, I just promised. This is the last example. I have a function, and I want it to be 2x divided by secant of x. Okay, so I have another quotient, and this is u, the numerator, and this is v, the denominator. So again, I'm going to use the quotient rule. So u prime, what is u prime? The derivative of 2x, 2 times 1, 2. And v prime, the derivative of v, secant of x. Okay, so my rule says, right, this is u. For this, I'm using the rule for secant of u. So what is that going to be? It says 1, because that's the derivative of x, times secant of u, secant of x, multiplied by tangent of u, tangent of x. So the derivative is secant of x times tangent of x. Okay, so these are my derivatives, 2 and secant of x times tangent of x. So I'm just going to write everything in my quotient rule. My quotient rule says v squared. Okay, so it's going to be secant of x squared, and then write v, the denominator. Okay, secant of x, there it is, and then multiply this by the derivative of the numerator, which is 2. Okay, I'm going to multiply by 2 minus u, the numerator, just copy 2x, and multiply it by the derivative of the denominator. Okay, the derivative of the denominator is secant of x times tangent of x. There it is, and this is the derivative. That's it. So I'm just going to get rid of all the brackets and the parentheses. I have secant square of x, and the first term, 2 times secant of x, is 2 times secant of x, and then minus 2x multiplied by secant of x times tangent of x is just going to be 2x secant of x multiplied by tangent of x, and that's it. This is the answer. Okay, I hope this isn't very difficult. Okay, you just have to follow all of the rules. Okay, the product, the quotient rules. Okay, if you have an addition or subtraction of functions, it's pretty much following the same thing. Okay, don't worry, we are going to get some practice with these exercises. Okay, thanks for watching.